Who's aware of the OCP Foundation? Right, that's lovely. Who could write a one-page on the technologies used in an OCP data center? Right, that's good. You?
Half a page.
Half a page, okay. Who could write half a page? Yeah, just one, okay. Now, as you can see, OCP is a kind of a bit behind in Europe. If I was in North America and I was talking to a load of bankers, I get a big hand up, and if Goldman Sachs were there, they would say, yeah, we know all about it because 90% of every server that Goldman Sachs buy is an OCP server. It's a piece of kit that's open sourced within the foundation. So the OCP Foundation is a not-for-profit foundation that started in 2011 when Facebook started to make its own gear, and then they just open sourced it all. And if I asked around the group how much of the world's hardware today is open source, OCP open source, any guesses? Anybody want to guess the kind of percentage of all the servers coming out of the manufacturing sites today? What percentage it would be?
20.
Yeah? I normally hear 2% when I'm in Europe, but when I go to America, I hear the 20 to 30% figures, which is much more realistic. If you study the kind of the well-known brands of manufacturers of servers, you'll find there's a massive decline on their business. You'll see a big shakeout in the boardrooms just in the last few months. The top people in two of the world's largest hardware manufacturing companies in IT have resigned from the boards. It's an interesting time ahead. So let's try and tell you why it's an interesting time, if I can. So this is me. I just help out 2 days a week. I used to own a company that designed and built data centers, and I got out of that business because enterprise data centers, in my book, are finished. They're finished. And when I talk about an enterprise data center, I'm talking about the smaller ones, the ones up to 50 racks. They're really finished. And you can see it. It's just, and yet you've still got these people. Like I was in Copenhagen last week, and you've got these companies, big companies that design and build enterprise data centers. And it was funny, one guy got up to do a presentation about data centers, and he started talking about hospitals, critical solutions in hospitals, because his data center business has gone down the pan. I thought this was a data center conference. He's talking about critical facilities in hospitals. It's really tough out there. Now, why is it tough? I believe we're going into a new industrial revolution, and it's causing all sorts of turmoil, and a lot of it's driven by software. Software is now starting to eat the world, and it definitely eats data centers. Where's our friend from eShelter? Hello. I'm with you guys tomorrow, and you might find this interesting because I'll just show you what software does to a data center, how it eats the data center hardware. Okay? But before I get to that point, I just want to show you what software is doing in other areas of the world on how it's eating things. Now, this guy here, he's a French guy, and he started BlaBlaCar. It's a car sharing system. And he knew he was onto a winner when he did a basic analysis of how efficiently cars are used. Now, this is something I took from an interview he did recently on the BBC4 Business Channel. And he said this. He said, in France, the average spend per car is €5,500. It's 38 million cars. It works out to be around about 10% of the GDP for France. 96% of the time, on average, the car is not moving. 0.5% of the time when you are moving, you're in a traffic jam. Then you're looking for parking. The actual function that you get the car for is travelling from A to B 2.7% of the time. But then, if you start to analyse even deeper, 3 out of every 4 journeys, I've only got one person in the car. So if you start to look at the effectiveness of the physical resource based on the seat, you can see it's less than 1%. Let me take you a little bit further. Now I'm getting into automation, I'm getting into autonomous vehicles. And these predictions, you can go and look at these predictions. You can see here on the left, I've got the standard car with the driver. The predictions are that when we get into autonomous vehicles, it's going to reduce the car manufacturing production by 80%. And the reason it's going to do it is because the software that controls where the autonomous car goes, you're going to utilise more than 1%. And therefore, you can drastically cut the physical resource. These are huge numbers. And this is why, who are the big investors in Uber? They're motor manufacturers. People are really getting interested in what software is going to do. There's a kind of a move at the moment. All companies perhaps will become software companies. These are capital values on businesses. It's really disruptive what's happening, and it's being driven by this concept, software and these technologies just eating the world. This is a very good video. These are all embedded videos in this PowerPoint presentation, and I've got a stick here. If anybody wants the PowerPoint presentations, you can get them on the stick because it's a very big file, and you might find it, unless you're going to transfer it onto some...
I'll be putting it online. I'll be making all of the presentations available to everybody online after this. Okay?
Yeah. So everything's there. If you want to reuse it, it's open source. You can reuse it. Now, what's interesting, it's really disruptive. You may have heard recently about the Uber in the UK. They're talking about trying to close it down. It's a lobby group from the black cabs. There's a petition was set up. This only happened last week. There's a petition. I think it's got 750,000 signatories on it now. They're not going to shut it down. But interestingly, that picture on the other side, that's Copenhagen. Copenhagen had Uber. But the regulatory body in Copenhagen insisted that all taxis have to carry a physical meter. Well, where's the powerhouse of meter manufacturing in the world? The Danes are brilliant at making meters. So you could argue there's a kind of a lobby group there. Uber just does away with meters. The software eats the meter, it just goes into the cloud. You can't, once something's been invented, you just can't stop it. Now, this disruption is really going to move on, and what you're going to start to see is you're going to start to see, I'd consider it to be silly short-term legislation to try and stop this. And this is a fascinating video to watch, because when blockchain and Bitcoin first came out, the Americans in New York legislated against it. They thought they could stop it. But software has this way of permeating around all regulation. It's so profound, software and these new technologies, that this will ultimately lead to the end of the nation state.
It's a big statement.
It's really profound. Just go and have a look at this. And in the end, this was a panel in the Canadian government about what they should do about legislating against Bitcoin. And in the end, they decided, we're just going to leave it alone. We're just going to let it happen. Now, this technology is going to bring down all the banks. But it's going to do more than that. The actual blockchain technology is really profound, what it's going to do. Just an example of some of the stupidity that you get when you start to get disruptive technologies. This is when the first automobiles came out in the UK. So we had something called the Red Flag Act in 1865. And you had to have a man walking in front of the vehicle with a red flag so that the car never went faster than 2 miles an hour inside a city or 4 miles an hour outside the city. And then it took them 30 years before they got to 14 mile an hour, even though the car could go much faster. Now, where I'm taking you here is this is all profound change, and the thing that's stopping the change, it's not the technology. This technology we're talking about now, these OCP technologies, the stuff that George is involved with Facebook and all these big hyperscalers, they've been doing it since 2008. That's a mature technology, but it's radically different to what most people know and love. And you've got to change the intuitive mindset before you're going to move on. So if I come back to my car analogy, I've got a server analogy. Now, what we did with servers, we used to run one application on a server. We didn't have any virtualization. We didn't use any clever software to kind of manage the resource. And then we started to manage the resource a bit better. So let's give you a kind of an example of what happens in a data center. In the beginning, I've got 10 servers, got no virtual machines. And then back in around about 2008, we started to see VMware coming in, first virtualization on these servers. That had a general reduction. If you counted the amount of equipment cabinets in a data center, they reduced around about 30%, 33%. But there's something else that's starting to happen now, and it's Linux containers, very, very lightweight virtual machines. You can run a lot more of them on the same piece of hardware. The impact, if I can run 3 times more Linux containers on the same piece of hardware, the implication of that is a 66% reduction in hardware. This is a very interesting story where software is eating hardware. As Facebook were building out all of their infrastructures, they just couldn't build fast enough the physical infrastructures. And one of the issues they had, where they had the bulk of the hardware problem, was on the front-end web servers, which are arguably about 80% of all the infrastructure. So they gave the problem of trying to make the application work better on the hardware, make it more efficient. And they gave it to a group of software engineers. The first thing they did, they developed a new programming language called Hack. And then they developed something called a hip-hop virtual machine. The consequence of the hip-hop virtual machine, it reduced the amount of front-end web servers they needed by 80%. Now, this is why these hyperscalers are doing what they're doing and taking over the world, because they're using clever software. And they're commoditizing all the hardware as well. And all of this is open source, by the way. You could go and download all this. You can run it on your own machines. But I doubt if anybody in this room is going to do it, because it's going to destroy. If you were the CIO of a business and you did this, you're going to basically put yourself out of a job in your own infrastructure. So it's really quite profound. Now, this is not just happening in the hyperscalers. All the world's telcos are moving to this. George, are you going to pick up on the telco stuff?
Yes.
George will pick up on what the telcos are doing, but they're basically... This is a sort of a nice diagram that kind of shows you how it all works. What you do, you break away, you unbundle the open source hardware, you run orchestration on top, and then you create virtual instances up the top where you might do network function virtualization. And this is what the world's telcos are doing. Just to give you an idea on the impact, for example, I think about 25% of Cisco's business is with the telcos. They're not buying it anymore. They're just buying commoditized hardware and then using clever software to create the function in software that the proprietary hardware used to do. So you'll see all these kind of traditional players moving out of hardware. You'll see companies like Cisco reorganizing themselves as a software services business. Because the likes of George sitting at the back there with a big smile on his face is getting all this network business down the bottom. And you can see it so clearly if you just look at the financial analysis of these companies. It's really profound. Now what I'm going to do, I'm going to show you what it does to a typical 40 to a typical rack with 40 one-use servers. How much time?
5.
And what I'm going to do, I'm just going to break it down.
5.
This is a typical server rack. I've got 3 top of rack switches. And what I'm going to do, I'm going to take the stuff out and turn it into an OCP rack. Take away the top of rack switches, because you don't use them. You only need 1. You take away those red things, they're the power, AC to DC power supplies. You don't have AC to DC power supplies in OCP equipment. So I'll take all those out. All those little round things there that have just been thrown away are 40mm fans. You don't use a 40mm fan, you use a different type of fan. The efficiency on the fan in an OCP rack is about 1/10 of the energy to just push the air through. And it's based on this, it's called the fan cube law. If you make the fan a little bit bigger and make it go slower, you save a lot of energy. If you take a fan and you reduce its speed by 50%, the energy to spin the fan is reduced by 7/8. Now, because we've made a configuration, a one-use server like this, we're forced to a 40mm fan. I haven't got time to show you all these servers, but you'll see they're a different dimension and they take bigger fans in them. So it's just simple stuff. So we throw all that away. Now these green things I'm throwing away are the intelligent power strips at the back of the rack. The intelligent power strips, they're about $1,000 each. Perhaps more if you're using the ones at 66 degrees. They're very expensive. And I'm just throwing them away. And what have the OCP Foundation done? They've replaced this with a copper buzz bar and a Raspberry Pi that cost $25. Now what's interesting about what the open communities are doing, they're not just doing things and changing it by like reducing by a few percentage points, they're doing it by double orders of magnitude. One other thing that they do, as a result of an OCP data center, you can reduce the amount of people in the data center by 99%. It's really profound what's happening. So this software it's all part of this software integrating into the hardware. Now what I'm also going to do, I'm going to throw away the crack units in the room because you don't need the crack units. That's an access floor with loads of cables in it. I'll throw that away. And I actually throw away the access floor as well. And what I've done, I've basically reduced all that legacy stuff. That's the sort of stuff I've taken out. Now, just to get your head around it, I'm also going to throw away a load of other stuff, but I don't have time to tell you about it. I've thrown away the centralised UPS systems. I may have even thrown away all of the standby gensets. Just as an idea, if you want to get this into your head, a traditional enterprise data centre might cost you somewhere in the region of $10 million per megawatt. An OCP data centre, you'll easily do it for 5. In fact, in Scandinavia at the moment, we're working on projects where they're doing it at 25% of that figure. Now, here's the proof that software's eating the world. Everybody says that, you know, things are really getting big and there's loads of activity. And there is loads of activity. And people are building out lots of big capacity in colo. And yet the hardware is declining. There's a real disconnect in the whole industry. This stuff is so disruptive and it's going to cause a lot of embarrassments as we move forward. But believe me, there's loads of opportunities. Now, I showed this slide last year, and you just read it, and it was a slide. It's an email sent to me by a good friend who could not get his company to listen about the changing world. And he had no order books. This guy was the senior sales guy for the whole of the UK, selling cooling solutions for enterprise data centers. Well, just to let you know that 6 months after he wrote this, he's now been made redundant. And so are lots of his colleagues. His company just wouldn't get the fix that they needed to change. So where am I going to leave you in this? The Kubler-Ross curve is what happens when something really close to you happens, where you lose something that you dearly love. It might be your dog, it might be a partner, and you go through this emotional turmoil. And all I hope where I leave you today is I hope I leave you here. Because if I've left you here, the only way is up. But you won't get there until you change your intuitive mindsets on what you currently believe is a data center. And it's radically different to what you believe it is. So thank you very much.